Okay, so now we have it, so now we can use it, and therefore just below we will actually call it. And in order to do this efficiently, we can just take the example here and right below we paste it, and we just replace once again yTrue by yTest, so that we can get indeed the accuracy on the test set. Okay, and here we don't have to do a print because this accuracy score will directly return that accuracy, that rate of correct predictions. So there you go, we can just play this cell, run this cell, and here you go, congratulations, you have here the confusion matrix showing that we have indeed 65 correct predictions of the class 0, meaning the customers of the test set who didn't buy the new SUV, then 24 correct predictions of the class 1, meaning correct predictions of the customers who bought the SUV, and then 3 incorrect predictions of the class 1, meaning 3 incorrect predictions of the customers who bought in reality the SUV but were predicted not to, and finally 8 incorrect predictions of the class 0, meaning 8 customers who in reality didn't buy the SUV but were predicted to buy it. Okay, so you see the confusion matrix has no mystery, it's very easy to read, and in a flashlight we can indeed get the main information of our predictions. And finally, that little number that we have here is of course the accuracy, and here we get 0.89, which means that we had 89% of correct predictions in the test set, and actually remember that there are 100 observations in a test set, which means that we had indeed 89 correct predictions. Actually, 65 here plus 24 is equal indeed to 89. All right, but for any size of the test set, this would mean that you had 89% of correct predictions. And that's exactly the accuracy. The accuracy is the rate of correct predictions. All right, so now you know how to, quickly evaluate a classification model. The accuracy is usually the right metric to use when evaluating your classification models. So now you have it in the toolkit. And so here we go for our final step of the journey. We're going to visualize not only the training set results, but also the test set results. And this will be super interesting because we will actually see how the logistic regression classifier was actually trained to classify our customers, our observations, into the 2 different classes, 0 or 1. We will have super nice results showing all the real results in both the training set and the test set, and also the prediction regions, the regions where our predictions are 0 and the other region where the predictions are 1. And you will see that the curve that separates these 2 regions is exactly the classification curve. And you will see that it will be a straight line for linear models and something else than a straight line for nonlinear models. I really can't wait to show you this because you will really see and visualize the difference between linear classification models and nonlinear classification models. So there you go, take a little break now and we'll tackle together this final step to visualize indeed these 2 results. And until then, enjoy machine learning.